Video, our goal is to solve sine squared alpha minus cosine squared alpha equals 1 numerically and graphically for alpha between 0 and 360 degrees. To solve the problem numerically means that in essence we're going to make a table of values and we're just going to kind of try and guess and check until we find something that works. So we'd start off with a value of alpha, and then we would evaluate sine squared alpha minus cosine of alpha, and we would just continue evaluating until we found a value that worked. So for example, if we try alpha equals 0 degrees, we would get sine squared of 0 degrees minus the cosine of 0 degrees. The sine of 0 degrees is 0. 0 squared is 0. The cosine of 0 degrees is 1. So we get 0 minus 1, and that's equal to negative 1. Unfortunately, we want to figure out where sine squared alpha minus cosine squared alpha is positive 1. Maybe next we would try 90 degrees. What is sine squared of 90 degrees minus the cosine of 90 degrees? Well, the sine of 90 degrees is 1, and 1 squared is 1. And cosine of 90 degrees is 0, and 1 minus 0 is 1. So that tells us that 90 degrees is one of our solutions. But when we're solving an equation, we want to find all the solutions between 0 degrees and 360 degrees that works. We found one, but you can see that this is a rather tedious process, and we have to rely on some luck in order to find the value that works. So we're going to use Desmos as a tool to make the table more efficiently. So let's go to the graphing calculator. The first thing we'll do is enter the expression. We want sine squared of alpha. Instead of using alpha, I'm going to use the letter A for alpha, minus the cosine of alpha, and again I'm using the letter A for that. Once I type in the expression, it gives me the option to add a slider. I'm going to go ahead and do that, and I want my A values to range from 0 degrees to 360 degrees. So I'm going to enter 0 as my lower bound for A. I'm going to enter 360 for my upper bound, and I'm going to enter a step of 15 because all of our special angles are divisible by 15. 30 divided by 15 is 2, 45 divided by 15 is 3, and 60 divided by 15 is 4. The other thing that we need to ensure is that our calculator is in degree mode. So I'm going to go over to graph settings and make sure that I am in degree mode. Right, now that I am, I can go ahead and start sliding the value of A to test the expression. And remember, what we want is for sine squared alpha minus cosine squared alpha to be equal to positive 1. When A is 0, it's negative 1. So let's just slide our A. See that the first value that we encounter is 90. The next value is 180. Next value is 270. And it looks like that's it. So using Desmos, we discovered that when alpha is 180 degrees, sine squared alpha minus cosine squared alpha is 1. And when alpha is 270 degrees, the expression is also equal to 1. So 90 degrees, 180 degrees, and 270 degrees appear to be our solutions. However, we were stepping by 15. How do we know we didn't miss a solution? So what we're going to look at next is how to solve this equation graphically. So to solve the equation graphically, the idea is to let y1 be equal to the left-hand side of the equation. Okay, sine squared alpha minus cosine of alpha. And let y2 be equal to the right side of the equation. And when we graph these equations, we're going to look for the points of intersection. So we're going to go back to Desmos. And I'm going to go ahead and enter y is equal to, in Desmos you want to enter y as a function of x, so I'm going to enter y equals sine squared x minus cosine of x. And for y2, I'm going to enter y is equal to 1. Now at first glance it would appear that these two graphs don't intersect each other, but the settings on my graph aren't conducive to finding all the solutions between 0 and 360 degrees. So let me go ahead and go back to settings. For the x-axis, I'm going to select my x minimum to be 0 and my x maximum to be 360. And I want to find out where the y values are equal to 1. So I'm going to go from -2 to 2. And for the x values, again, I'll use a step of 15. And now we can see the graph more clearly, and we see that there's 1, 2, 3 points of intersection. If we click on the first one, it tells us that 90 degrees is the first solution. For the second one, 180 degrees is the solution. And for the third one, 270 degrees is the solution. So graphically, we see that there are 3 solutions. 90 degrees, 180 degrees, 270 degrees. Those correspond with what we found numerically, and it doesn't appear like there's any other solutions between 0 and 360 degrees. So coming back to our whiteboard, we have our graph here. We have y1 and y2. And our goal was to find out, where do these graphs intersect each other? One intersection point was here, and that corresponded with 90 degrees. We had another intersection point here, which corresponded with 180 degrees, and another intersection point here, and that corresponded with 270 degrees.